So if I asked you to take the derivative of sine to the fourth x over 4, you would, again, treat this as if it was the sine of x to the fourth over 4, and then you take the derivative, so your 4 over 4 would become 1, so you've got the sine of x cubed, right? So the sine of x cubed, and then the derivative of the inside part, which would be cosine of x. So if we wrote this out, we would say is sine cubed x cosine of x. That would be the derivative of this. So would it not be safe to say that the antiderivative of sine cubed x times cosine of x dx would equal to that family right there? If the derivative of this is this, then the antiderivative of this should be that family right there. But the thing is how would we know that? We don't have a product rule or anything like that. So how do we go about knowing that bit of information? Well, we have to think about what was done here. It was a chain rule, right? We used the chain rule in order to solve this out. So if we're going to use the chain rule in order to solve this out, what I can do is in a chain rule, I know that I have a derivative of an inner part and an outer part in there. So what I'm going to do is I'm going to do a method called substitution. And I'm going to say that u is going to be the sine of x. Because think about this. This would be u to the fourth power at that point right there, right? And in here you would have u to the third power. Now, not only do we have that value in there, but its derivative is also in the antiderivative. So du would be cosine of x dx, right? So I'm going to go about substitution here. In the place of sine of x, I've got u. So this becomes u cubed. And in the place of cosine x dx, I have du. So my problem here has gone from what is the antiderivative of sine cubed x cosine x dx, it's all of a sudden become what is the antiderivative of u to the third times, or u to the third du. Well, how would I anti-differentiate u to the third? Well, it becomes u to the fourth over 4, right? Plus some constant. But now we have to take into consideration what was the original problem. The original problem was in terms of x, so I take this u value and in its place put sine of x. So it's sine of x to the fourth over 4 plus c, which we could, of course, write as sine fourth x over 4 and plus c. Is there a question about that? Now, there are a few things that are happening here in doing u substitution problems. First off, you may not pick the right thing to be u every time. And if you go through a problem and you pick the wrong thing for u, you're going to have to do the derivative of it somewhere in there. And when you do the derivative of it somewhere in there, you're going to see, oh, wait, that's nowhere in this original problem here. So you know, hey, I've got to start back somewhere else. So that'll show itself up. So main thing on substitution problems, sometimes you're just going to run into one that's just going to be tough. Sorry, I got to quit smoking. Sometimes you're going to run into one that's just a little bit tough. That was supposed to be a joke. It's a little bit tough. But the main thing is you start somewhere. Because if you start somewhere and there is a mistake, a lot of times you kind of get a picture of what patterns are happening in the problem, and you think, oh, okay, I can avoid this mistake if I just try something a little bit different in here. So your main thing is when you get to substitution problems, and these do get difficult. When you get to the substitution problems, just try something, and then go from there and see what happens. So let me give you one. I'm not going to start off this problem right here. You know, I started off and I showed you that the derivative of this function was this, but this time we're not going to know what the answer is in the end. We're just going to go through and try a substitution problem. So let's say that we have x squared times x cubed plus 7. Now, if it was just this problem right here and nothing else was added to that, I would just distribute in the x squared and that problem would be easier to work. But I'm going to throw a fourth power up here. And once I throw that fourth power up here, now all of a sudden, this problem, I don't want to raise that out to the fourth power and then distribute in the x squared. That's going to take a while. So I'm going to, again, it's a product, so I'm going to consider the chain rule here. So a lot of times a good start is if you've got some parenthesis raised to an exponent, use that one. Other things to look for is where is the biggest exponent, what's got the most terms involved in it. So try doing that. Because the reason I say pick what has the largest exponent in it is the derivative of x cubed is a form of x squared. But a derivative of x squared is not a form of x cubed. So you want to pick something where its derivative or some similarity to the derivative is in there. So I'm going to let u equal to x cubed plus 7. So what would this derivative be? No, the derivative, not the antiderivative. 3x squared plus, just plus, I'm not plus anything, just dx, right? Okay. Are we okay here? All right. Now, from here, let's look at setting this up. All right, I've got this value to the fourth power, and that was u. So I've got this u to the fourth in here. Now, what have I not used? I haven't used the x squared dx, right? All right, now, I know that 3x squared dx is equal to du, but I have an x squared dx here. So what I'm going to do is I'm going to say that du over 3 is equal to x squared dx. You follow what I did there? Okay. I needed an x squared dx. I had a 3x squared dx. So to get this to become x squared dx, yes, I had to divide by 3. Are we okay here? All right. So now I'm going to say it's u to the fourth times du over 3. Well, with that constant involved in this problem here, I'm going to factor it out. So this is now going to become 1/3 of u to the fourth du. I can factor a constant out of an integral. I could not factor out a variable. If I have a u in there and that u's in the way, I can't factor it out. Actually, there is a way, but it's not covered in AP Calculus AB. It's covered in BC Calculus. But anyway, we're left here. So what is the antiderivative of u to the fourth du? Very good. So I've got 1/3 times 1/5 u to the fifth plus a constant, right? Okay. So what's 1/3 times 1/5? 1/15. And then I have u to the fifth. And then what's 1/3 of a constant? It's still a constant. So I've changed everything you ever learned in multiplication of variables. If you ask an Algebra 1 student what 1/3 times c is, they'd say 1/3 c. But here in calculus, 1/3 times c is still c. But that's because it's just a constant. And 1/3 of a constant is still a constant. All right, now, what is u? U is x cubed plus 7. So now I have 1/15 of x cubed plus 7 plus a constant.
Where did du go?
The du, remember, I see. When you do the antiderivative of the du, it goes away with the notation with the integral symbol there.